Hello everyone. The topic for today's lecture is function scope. Before I dive into today's lecture, I want to do a quick review of the topics that have been covered so far in this semester. We learned the term pseudocode, which refers to step by step instructions for solving a particular problem. Then we learnt about expressions, which are combinations of operators and operands. We covered basic mathematical operators like addition, subtraction, multiplication, and so on. We also learnt new operators like modulo operator, Boolean logic operators of and, or, and not. Operands can either be literals or variables. Literals are fixed values. Examples of literals would be 10, 10.0, string hello. A variable can contain either a literal or the result of an expression. Then we learnt about functions. Function is the first exception for in order execution. The relationship between variables and functions is so complex that it warrants an entire lecture. We already know how variables are created. When you use the assignment operator to assign or initialize a value into a variable, that particular variable gets created. In today's lecture, we are going to learn when variables die. We are going to understand rules for local variables, global variables, and argument passing. I'll be covering 10 rules which will enable you to understand the relationship between functions and variables. These rules are specifically applicable only to the Python programming language. Other programming languages might have different behaviors. We'll be covering examples where we have different variables that have the same name within different functions. Today's lecture is conceptually challenging. I would encourage all of you to go through all the example problems that I go through as part of today's lecture. Once you've reviewed the examples, please attend office hours if you have any clarification questions. Let's get started by talking about context. Often in life and in programming, the same name can mean different things depending upon the context. Let me give you concrete examples. Every semester, I look up what is the most common first name among the CS220 and CS319 students. This semester, apparently, we have 11 Ethans. Let's say that I get all the Ethans together into a single room and I'm posing the following question. Ethan, what do you think about this? Whom I am referring to depends on whom I am pointing at when I ask such a question, correct? Similarly, a given street address can refer to different buildings in different cities. For example, 534 State Street would mean a specific building in Madison, whereas it would mean an entirely different location in Washington, D.C. Let me give you examples in programming context. Last lecture, we did a demo for speak function inside the cat module and dog module. Which particular speak function I'm referring to depends on how the function call is structured, correct? When I say cat.speak open parenthesis close parenthesis, I'm referring to the cat module speak function. By now, all of you would have created multiple files called as main.ipynb. Which main notebook file that we are referring to depends on the current working directory. As I mentioned, programs can have different variables that have the same name. So, how do we keep track of variables? How do we organize them? How do we know what variable name we are currently referring to? Frames are the concepts which enable us to organize variables within the program. In order to understand variable name context, we'll be learning a set of rules. Let's learn about frames first. You can think of frames as boxes which hold variables. Every time a function call is made, a new frame gets created. There is a common frame called as global frame, which is accessible for all the functions. When you initialize a variable outside any of the function definition, that particular variable goes into the global frame. Any variables inside the global frame are called as global variables. Any variables inside a function invocation frame are called as local variables. When you execute a particular program in Python and you're using a variable name inside your function, Python looks for the variable name definition first inside the current function invocation frame. If it cannot find a defined value for the variable in the current function calls frame, it will look for the variable inside the global frame. If it cannot find the variable definition inside the global frame as well, then your program execution will crash. So whenever you're running a specific function call, that particular function call has access to two sets of variables, the local variables inside the function calls frame and the global variables inside the global frame. Let's go through an example to understand the concept of frames. Here is an example from the Think Python book. If you were thinking that Python programming language is named after the snake Python, then that is not correct. It is named after Monty Python. Here is a song from Monty Python. Let's understand various aspects about this particular program here. We have two function definitions. The first one is for the print underscore twice function, and the second one is for the cat underscore twice function. Then you're initializing two variables, line 1 and line 2. Finally, you're calling the cat underscore twice function in line 11 here. What sort of arguments does this function call have? They are positional, correct? That's because I don't have parameter names associated with the arguments itself in the function call. Recall that positional arguments line up with the corresponding parameters. So line 1 argument is going to line up with part 1. So part 1 here is going to contain bing tiddle. Similarly, part 2 is going to contain tiddle bang. Inside the cat underscore twice function, we are concatenating part 1 and part 2 variables using the plus operator. Then we are invoking the print underscore twice function by passing cat as the argument. This positional argument of cat lines up with the parameter Bruce. Inside the print underscore twice function, we are calling print function twice to display Bruce. So the output of this particular program is going to be bing tiddle tiddle bang, bing tiddle tiddle bang in 2 lines. Let's understand frames with respect to this particular example program. When you're initially starting the program execution, you will initialize the variables inside the global frame. You'll put the variables inside the global frame. Line 1 and line 2 variables are defined outside any of the functions. So those are going to be part of the global frame. Then you have two frames for the two function invocation for cat underscore twice function and print underscore twice function. When you're running the print underscore twice function, there will be three frames that are part of that particular program execution. You'll have the print underscore twice function call frame, and then you'll have the cat underscore twice function call frame because you're calling print underscore twice inside cat underscore twice function. And then you'll finally have the global frame because you're calling the cat underscore twice function inside the program which has the global frame. You don't interact or see frames in any way when you're writing programs in Python. You don't write code for frames, but it is important for you to get a good mental model about frames because that will enable you to get a good understanding about variables scope. I'll define scope shortly. Here is an example diagram from the Downey book. The diagram is stacked as stacked diagram. Sometimes frames are referred to as stacked frames. Let's try to understand the frames here. The first box is the global frame, which holds the variables line1 and line2. The second box is the cat underscore twice frame when we call the cat underscore twice function call here. Inside the global frame, you can only access the variables line1 and line2. Once you call the cat underscore twice function, you can access both the global variables which are line1, line2 and the local variables which are part1 and part2. Observe that part1 and part2 are parameters. Recall that parameters are nothing but special variables, so they also go as part of the function call frame. In the print underscore twice function frame, you can only access global variables of line1, line2 and the local variable of Bruce. Even though cat underscore twice function called the print underscore twice function, you cannot access part1 and part2 variables inside the print underscore twice function. So let me define the term scope. The variables that can be currently accessed are called in-scope variables. For example, print underscore twice function frame has line1, line2 and Bruce variables within scope. And the variables that cannot be accessed are called as out of scope variables. Print underscore twice function cannot access part1 and part2. So part1 and part2 are out of scope. When you're passing arguments to parameters in a function call, the arguments are passed by value. What exactly is passed by value? You'll be copying the value over to the parameters. So you'll be copying Bing title string over to part1 parameter from the line1 argument. This will be different in other programming languages. This is just Python's behavior. Let's understand the differences between Downy visualization and Python tutor visualization. The first difference is that Python tutor uses boxes to show the variable values beside the variable names, whereas Downy uses arrow. Recall that we can switch the Python tutor view to show arrows, but for now we are going to stick to the default value which uses boxes. The second difference is that Python tutor uses the term global frame, whereas Downy uses this Python keyword which is underscore underscore main underscore underscore. We'll not be talking about this particular Python keyword in CS220, so we'll be using the term global frame. The third difference is that Python tutor also shows function definitions in the global frame. For now, just ignore that. Eventually, we'll learn what those mean. I'll be giving you guidance as to how you can review the problems that I go through as part of today's lecture. I would encourage all of you to just watch the lecture video without following along in order to understand the rules. Once you're done watching the lecture video, you have a couple of ways for reviewing the demo problems that I show to cover the various rules. The first way would be for you to use the slide deck. The problems that I cover are given as part of the slide deck itself, so you can take the problems from there and try to run those within Python tutor on your own. Alternatively, you can go to the course website, today's lecture entry, and click on interactive exercises. The interactive exercises have all the problems that I'll be covering in addition to 3 practice problems. Please make sure to use the interactive exercises tool to review the problems to get a good grasp about the rules. Don't memorize the examples themselves, but try to get a good understanding about each of the rules that I'll be covering. I'll wrap up this video here. In the next video, I'll provide rules for local variables.